Okay, for this problem, we're going to invite my childhood hero, Sally Ride, first American woman in space, also first, later on she came out, gay astronaut in space that we know of. And so let's go through the different things that are in the problem. Hang on, my computer just turned off. She experiences a force of 146 newtons and for a time of 125 seconds. So what is the impulse acting on her? So impulse is equal to force times time. Hey, sorry if there's noise. My husband's making food in the background. So let's see. Impulse is equal to force times time. So we're going to do 146 times 125. So impulse is equal to, let's see. Okay, throw that in a calculator. You get 18.250. And the units would be newtons per second. So that gets us through part one. So what is the impulse acting on her? And then the next question is, if she starts from west, what is her final momentum? So our change in momentum is equal to impulse. That's a really key idea. 90% of the time when you're struggling with an impulse problem, it's probably because you forgot that. So how does that help us? Well, impulse is equal to change momentum, which is P final minus P initial. So impulse is equal to, well, her initial momentum, she's starting from rest. So we're going to have 0 here. And we don't know her final momentum when she's really booking it. So we have 18250 for her impulse. We don't know P final minus 0. So what's her final momentum going to be? 18250 newtons times seconds. Or you could have written kilogram times meters per second. Some of you may not have actually done that work. You might have just known it, kind of in your gut from knowing that the change in momentum is equal to impulse, and that's fine. So if her final momentum was this amount, and her mass was 55 kilograms, and what's her final velocity? We could just do P is equal to mv. So we have 18250 is equal to the mass, which is 55, times the velocity. So the velocity we get, how fast is she going? This is very fast, 331.8 meters per second. I think the speed of sound is 343 meters per second. So she's bombing along. Awesome.